Hello and welcome everyone in this new exciting series of lectures related to purifier. So in this series we are going to study the manual of the purifier, that is basically Samgong Mitsubishi self-ejector manuals. So here we see in front of our screen is the operational manual 1 for the self-ejector series. So what we see in this manual is basically the description of the components, etc. So we'll see one by one how this manual unfolds. Okay,
to every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
let me just take you through this manual. So this part is the operational manual 1. Okay, in the operational manual 1 we have got the precautions for safety, configuration and construction of the self-ejector manual, self-ejector purifier, motor starter, automatic control panel and multi-monitor related items. So we'll see one by one. So the first section will be about the configuration and construction of the self-ejector. So first we will go through a few definitions. Okay, so we'll start our lecture with a definitions related to purifier operations. Okay, so first term here is density. So density is a very common term which means mass per unit volume, right? The amount of the liquid or the solids, like your, so we have sludge, water and oil in our purifier operations. These are the three components that we will be talking about. So we will be talking about the density of these three elements, because the volume that the purifier contains is common for every element when we are doing a centrifugal separation. So basically our purifier is a machine that works on centrifugal separation. So the density of each one will be the factor for the separation. So if we talk about here, if I draw the basic diagram of a purifier, okay, so this is very basic diagram of the purifier. This is basically the purifier bowl that I am drawing. Okay, okay, so roughly, only to explain the diagram, here will be your vertical shaft on which this bowl will be rotating. Okay, this is your male seal ring, and we have the two components. This is the sliding bowl which opens. Okay, basically the concept of centrifugal separation. So when the vertical shaft rotates, the bowl assembly rotates along with the vertical shaft at a very high RPM, around 9000 RPM. So when what happens is when the oil, which is having three components, water, solid particles, that is we call it sludge, and oil, pure oil, which is the treated oil. So according to their density, so water will have a density around 1000 kg per meter cube. Sludge will be having density which is higher than water, which is above 1000, okay, greater than 1000, and oil will have less than 1000 kg per meter cube. So because of the difference in density, the heavier the particle, the farthest. So force is equals to m omega square r. So mass, so centrifugal force that will act on the particles will be as per their mass. As we can see here, force is directly proportional to the mass of the component. So if these components have different mass, like sludge will have more mass, so sludge will accumulate at the farthest corner, then comes the water, okay, and then comes your treated oil, okay, right. So depending on the density, the separation or the centrifugal separation will take place. So the basis, the very basis of separation here in a purifier is the density, okay. So now coming to the second definition, which is specific gravity. Specific gravity, what is specific gravity? So when we have spoken about density, specific gravity is nothing but the ratio of two densities. Say when we are talking about specific gravity, we erase this one, okay. Let us talk about specific gravity. Specific gravity. What is this? This is the ratio. Ratio of what? The densities. Say we are talking about the density of water. Specific gravity is the ratio of densities between the, say, ratio of density of oil. So density of oil with respect to the density of water, okay. Say if oil has got the density 991 kg per meter cube volume, so 1 meter cube is the volume at fixed volume, and water has a definite density 1000 meter, that is normal density of water that we take, 1000 kg per meter cube, okay. So the specific gravity is a dimensionless quantity. You see here kg per meter cube has been cut, दोनों कट हो गया, तो स्पेसिफिक ग्रेविटी कितना हो गया 0.991. So this is a dimensionless quantity. 0.991 is the specific gravity of oil, or denoted by gamma signal. That is the oil's specific gravity with respect to water. Some maybe we will talk, if we talk about the sludge, तो sludge का specific gravity क्या हो जाएगा, और gamma of the sludge, so it will be sludge specific gravity will be density of sludge with respect to density of water, ठीक है. अब sludge का मान लीजिए you have the density as 1018, which is above the density of the water, kg per meter cube, and water's density is 1000 kg per meter cube, right. So these have been obsolete. Now it becomes how much? 1.01, that is above 1. So sludge density or sludge specific gravity will be more than water specific gravity, right. Sorry, यहाँ पे कट कर दीजिए. So sludge is having a specific gravity of 1018. Okay. Also, since we are talking about density also varies with temperature, so the specific gravity also will change with temperature. So as you will increase the temperature, specific gravity will change, because volume changes with change in temperature, so does the specific gravity changes with change in temperature. Okay, come to oil feed rate. Oil feed rate is nothing but, say we have to send oil into the purifier for purification. So feed rate, when we are talking about, is basically the amount of oil sent for purification per unit, because it is rate when you are talking about rate, we are talking about unit time, per unit time. ठीक है. So say we are sending 4000 liter per hour or 4 meter cube per hour. This is the feed rate for the purifier. Okay. So volume per unit time of untreated oil. Okay, upstream the purifier, sending inside the purifier. Untreated oil, that is the dirty oil from the settling tank that needs to be purified, that is sent is the purifier, is the oil feed rate. ठीक है. Okay, now moving ahead, we have actual capacity. Actual capacity, if you see here, actual capacity means as per the SM standard. SM standard क्या होता है? SM means Samgong Mitsubishi SM. They have designed the purifier for a certain treatment capacity that you cannot send any kind of oil or any kind of oil with specific gravity, say higher than this value, to separate for a given kind of a purifier. So treating capacity or the actual capacity is maker's design for the purifier. So when we talk about say SJ10 model or SJ20 model, so we are actually determining the amount of sludge, amount of oil that can be feed rate will be defined. So feed rate will be fixed for a type of oil, cannot vary from say 5000 to 10,000 liters. Okay, so there will be a set value between some figures, say 2000 to 4000. You cannot exceed this amount of feed rate, otherwise the oil will come out from the dirty oil outlet. It will exceed the capacity of the purifier. So that is actually the treating capacity. So how much oil the bowl can actually contain means the actual capacity or the treating capacity of the purifier. Okay. What is feed liquid? So when we talk about feed rate, the liquid that we are sending into the purifier is called the feed liquid. Okay, untreated oil from the settling tank is called the feed liquid. ठीक है. What is light liquid? Light liquid is the treated oil from the purifier. Okay, so the purifier will purify the oil as per the density. So the least density oil which has got which is the treated oil will be coming out from the light liquid side, which is called the light liquid, purified oil. ठीक है, simple. Heavy liquid. So when we talk about heavy liquid and light liquid, see, heavy liquid is water which has got more density. Okay, so higher the density is the heavy liquid and the lighter is the density is the purified oil. So heavy liquid is water. Okay, now come to sludge. So there are three components of a purifier oil. So your untreated oil that you send inside the purifier is basically divided as per their density due to centrifugal separation into three components: light liquid, heavy liquid and sludge. So basically when we talked initially, right, we talked about the diagram of a purifier where we had seen how the liquids are separated. So you have the heaviest component at the corner most part, that is the sludge. Okay, so the solid particles are called the sludge. Okay, or the heaviest particle. So heaviest as per the density is sludge, then comes the heavy liquid and then comes the light liquid. Okay, solids accumulated in the ball towards the outer periphery. Okay, now what is the interface? So interface basically is a boundary layer, boundary surface, okay, boundary surface between which two components, between the light liquid and the heavy liquid. So if we draw this one, say if this is the rough sketch of a purifier and this is your disk stack, okay, this is the top disk and this is the outer disk, the disk stack, okay. So you have number of disks like this arranged one over the other, okay. So the interface is a boundary. Depending on the density, it will be varying from the tip of the disk stack to the tip of the top disk. So it will either be somewhere here or it will be somewhere here, but it will not be outside this section. If it goes, say the interface goes outside here, so what will happen, say here, so what will happen is your light liquid will go out from here and will go out into the heavy liquid side and will go into the sludge tank. If your interface is somewhere shifting here, that means the water will go enter into there, rise through this discs and this stack and go into the light liquid. So basically the interface is creating a boundary layer between the two liquids, the lighter liquid and the heavier liquid, and it should not change the position. It has got a fixed position lying from the tip of the disk stack to the tip of the top disk. Now we will see the purifier operation. So as we have discussed also, purifier is basically separating the feed into three components or three phases. One is light liquid, one is heavy liquid, okay, and the third phase is the solid phase, which is sludge, okay. Light liquid is the purified oil, heavy liquid is the water, and the sludge is basically mixture of solid particles and water, basically solids at the outermost periphery. Okay, now come to clarifier operation. Clarifier and purifier. So clarifier, actually, if you have heard the word clarified butter, so when what we are doing churning. In that clarified butter we get the solid fat of the milk at one place, and then rest say liquid with solids are separated out, okay. So basically clarifier operation is separating the feed liquid into two phases. Feed is separated into two phases. One phase is the light liquid phase and the other phase is sludge phase. So sludge here contains your water, sludge plus water, okay. Sludge plus water is the second phase, that is the clarifier operation, okay. Then comes to parallel operation, okay. Parallel operation is basically when you have two purifiers, say on board we have two HFO purifiers, and we have got a dirty oil or the oil having more water content or cat-fines are more. So what do we do? Let's understand this operation. What do we do here? What do we do is say if you have dirty oil and we reduce the feed rate, if we reduce the feed rate, say normal feed rate for the purifier is 4000 liters, what we can do is we can supply that oil to two purifiers, 2000 liters each. Okay, the reduced feed rate will allow the feed oil to go inside the purifier at lesser feed rate, at less, so the amount of oil that will get separated will have more time for separation. When you have more time for separation, the quality of separation will improve. Okay, so if you are giving oil or feed rate which is small in quantity, okay, so the light liquid particles will be having more time for separation, and a better separation can be achieved through this parallel operation. So generally on board what we carry out is parallel operation, two purifiers kept at a minimum feed, so equal feed to both the purifiers, and we get a better output sent to the service tank. Okay, so that is parallel operation. Now series operation. Series operation is when we have to separate one purifier's oil, treated oil, and we feed this into another purifiers, say purifier 1 and purifier 2. So feed is coming to one purifier, untreated oil from the settling tank, and the purifier is purifying it and sending it out. Instead of going to service tank, it goes to the feed of another purifier, and the purifier gives the purified outlet to service tank. Generally on board we avoid any series operations, we carry out parallel operations. But say in case, so there is a question, if in case you have a purifier and a clarifier on board, then what would be ideal? So to place a purifier in the first or to place a clarifier in the first. So first will be the purifier operation or the clarifier operation. Purifier may we know that it is separating into three components or phases, clarifier is separating into two phases. So the answer to this we will discuss at the end of this lecture. Okay. Total discharge type. This is saying about a type of purifier which is discharging all the content in the bowl at one desludge. So that is total discharge type purifier. So jab bhi desludge, whenever there is a desludge operation, the bowl opens, the main cylinder slides down and everything goes out. That is total discharge type. Then another type of purifier desludge is a partial desludge operation or partial discharge type purifier. So in this manual we will also study about the partial discharge function of the purifiers. So partial discharge type purifiers discharge solid and water. So partial discharge, how they do is, so they will open for a very small period of time such that the outer periphery, the solids and water contained at the outer periphery are discharged out as the ball slides down, and then again it sits back. So basically advantage is that the desludge time can be increased, the oil purification can continue. Okay, your content of inside of the bowl is not going outside. Okay, so you don't need to send displacement water, that we will see in details later on, displacement water etc. But basically partial discharge advantage is that we can increase the desludge time, where we can remove the sludge and water contents for a shorter period of time. This type of purifier also has got a total discharge function. So sometimes when the sludge and water increases to a extent, then we have to do a total discharge also for this kind of purifiers. Okay, now there are some abbreviations in the end. We know this: liters, hours, per minute is the revolutions, frequency, phi here is the unit of diameter, mm square per second is the unit of viscosity, which is also called CST. ISO is the standard organization which establishes the standard for marine fuel oil also. Okay, VG is basically the ISO standard for the lube oil. So for fuel oil you have ISO standard. Okay, lube oil is the VG standard. VG is the for lube oil, viscosity for the lube oil. Okay, so coming to the question that we had asked. So if we have one purifier and one clarifier, and we have to use both of them in series, the first one has to be the purifier. Why so? So if in series we are using, the purifier will separate the feed into three components. One is the treated oil or the light liquid, then heavy liquid and sludge. So whatever is the outlet of the purifier is the treated oil. The treated oil might contain a little bit amount of sludge and water. So the clarifier can easily separate the sludge out and you will get a light liquid outlet that is more purified, in more cleaner than the previous liquid. Okay, now consider the scenario where we place the clarifier first. So if you place the clarifier first, say if you place the clarifier first, and then we place the purifier, what will happen? The clarifier is separating out into two phases. One phase is light liquid and the other phase is water plus solids or this sludge. But in purifier what happens, since we have not separated out the water, there is a great chance that this light liquid which is coming out is containing a greater amount of water in its content. Okay, and this water, because since it was not separated out and there was a centrifugal separation going on, the water plus light liquid or heavy liquid plus light liquid generally tends to form a emulsion. Okay, so this emulsion, which is a mixture of water and the oil, is very difficult for the purifier to be separating. Okay, so if in the next stage the purifier is getting this emulsion of water plus oil, the purifier is not effectively able to separate it out. That is why we keep purifier at first and the clarifier at second. So it's a question that is commonly placed. Okay, so that's it for this part of the lecture. In the next lecture we will see the other details. Okay.